Hi, everybody. I'm starting this up a little bit early since this is my first YouTube stream. A little rough today, but let's see how it goes. If you have questions, start to think about them and obviously put them up in the chat window. Again, I'll wait a couple more minutes, see who shows up, and we'll go from there. If you're watching this live, for a little natural feedback, can somebody just say something in the chat window so I know it's coming through? Oh, good. I appreciate that. I'm gonna wait another minute or so, then we'll get started. Well, hello. I hope you're doing well in Germany. Let's see, what time of day would that be there? Is it like 10 or 11 at night? Well, let me know what time it is there. It'd be interesting. We'll get started here in about 30 seconds. 2200. Okay, 10 o'clock. Okay, well, thank you for staying up. That's about time I start thinking about going to bed. All right. Get a drink of water. Let's see here. I want to verify that it's streaming regularly. Yeah, it looks like it's all working okay. All right. Okay, well, we'll get started a little bit. A couple people here I recognize from my the Zoom meetings that I've held for the last several months. Since mid-March, I've been doing first bi-weekly, then later it was monthly Zoom techniques and methods and equipment and all kinds of things. Doing that on Zoom. But there are certain sort of limitations regarding Zoom. And I always wanted to move to a YouTube stream, but never really have had time to mess with it. So regarding the people that are on my subscriber list on my website, which is woodworking.digital, and I encourage everybody to subscribe, of course, with the subscribe button on YouTube, as well as subscribe to my mailing list at woodworking.digital. So we've had quite a number of people at those events on Sundays, and I've covered lots of different topics, everything from very specific things, very specific techniques and methods to design methods that I use and some of the approaches that I take to design. So in this particular meeting, I'm going to make it mostly a Q&A. I do have a couple things to show. Regarding those Zoom meetings, I want to go backwards here a little bit. Regarding those Zoom meetings, I'm no longer going to hold those on a bi-monthly basis, or excuse me, on a monthly basis. The amount of people showing up is in the low 30s, in that kind of range. And it takes actually a fair amount of time to prepare for them. And with the workload that I have, which is really high right now, I'm going to put off those monthly Zoom meetings. However, that said, I still intend to do some more or less private workshops where we get, anywhere from 4 to 6 people together. These would be paid workshops, and we take on a particular project that would stretch out over many sessions. So that'll still happen. In terms of YouTube stream events, I'm going to leave it a little bit open for now because of my workload. So some of the things that I've been working on for a while, the last Zoom meeting that I did, I alluded to a bench that I had been designing for quite some time and working on an article for Popular Woodworking magazine. I'll have a little bit more to show about that and to talk about that here in a few minutes. So let's start off with questions. I've got lots of nice greetings. Is there anybody else that has a question they want to ask regarding digital woodworking? Nothing right now? Okay. Well, for those of you that have endured those Zoom workshops, it's kind of, but I have a little under 2,000 followers on YouTube. And if you're some of those folks, I thought what I do is sort of discuss a little bit about my background here a little bit. My primary background is as a designer. And in my case, that started originally in architecture. It led to graphic design, where I had a very long career. And then I took up the hobby of woodworking. And by that point, which would have been in the mid 90s, I'd already had pretty good skills. So when I got involved with woodworking, I, excuse me, I certainly focused on building up a range of skills, that are standard to woodworkers, from hand skills to machine skills to all kinds of things like that. But I already had some strong digital skills. I was pretty comfortable with these tools. So from the time that I started woodworking, I was using digital tools, particularly drawing programs that I was comfortable with. And it didn't take long from the time that I began to go ahead and apply those to woodworking. In essence, I would create my designs using digital tools, but I also started CNCing out my patterns. And that led ultimately to a career where I've had a long career as a furniture maker. And all of my pieces that I make in my main line of furniture, which is about 150 different items that fall into 6 design groups, all of those were designed using design software, and the patterns were CNC'd out. So I got a first question here. Let me move in here a little bit. It says, I've always used AutoCAD for drawings, now use NanoCAD. What do you use for basic CAD drawings? Well, when I started out, actually, because I was a graphic designer, I started using the tool I was most comfortable with, or tools, and that was Illustrator and a program that's long gone called Freehand, which was a competitor to Illustrator. So after that, when I finally decided to get a CAD program, I started using a program called Rhino, or Rhino 3D. It's made by a company that's Seattle-based here. They're a small company. Company is called McNeil and Associates. And I just sort of immediately fell in love with the program. It had the user interface that I was looking for, that I didn't in other programs that I saw that I wasn't as comfortable with. And to answer your question more specifically about basic CAD drawings, one of the great things about digital woodworking, where you're using CNCs to cut out parts, say, and things like that, it really only takes a very simple CAD program. Very simple programs work out really well. That said, and I want to make this point, I've made it many times in other environments and other situations, don't rely on SketchUp. SketchUp is not a particularly good tool when you're ultimately going to CNC. And the reason is it outputs files that are kind of a disaster when it comes time to actually get something on a CNC. And there's no really simple way to correct those files without having to redo portions of a drawing. It's just the way SketchUp works. So whatever you choose, whatever you do, I encourage you, don't use SketchUp. That's just not the best possible choice. Again, if there's other questions, let's see here. I have a project to create 50 copies of a project made from Baltic birch. Do you have experience using RhinoCAM to cut out a set of multiple nested parts? Yeah, actually, I do have a lot of experience with that. In fact, the new workbench that I'll show you here in a few minutes is built on that idea. So the first thing you said is multiple nested parts. You're going to make 50 parts. If you're using RhinoCAM, any version from Express, which I think is $5.99, but they have it on sale for like $3.99 here for a couple of weeks. If you have Rhino, that is definitely the CAM program to get. It's a superb program. It's easy to learn. It has huge amount of control. And as your skill sets or your requirements change, you can up your version to get more features. So, but all versions of RhinoCAM now include what used to be a separate product for nesting. It's Rhino, I don't know if it's called Rhino Nest or whatever, but it's a nesting program. And what that means is you could take a board, let's say you're cutting 50 parts out of, Well, I'm just going to go back here. So let's say you're taking a board that's as big as this here. Hopefully you guys can see the edges here. And I'm cutting 50 small parts. The nesting program will distribute all of those parts to your requirements within this space. When I say to your requirements, in some situations, grain matters. Let's say you're using a nice laminated or a surface kind of you laminated on a veneer of some sort of like beautiful streets of oak or something like that. You might want to have all the grain go in the same direction. So you can even choose that the direction of the parts are laid out. But beyond that, you put in some pretty normal restrictions. So for example, I make a habit of always standing an inch off from my edge in terms of distributing the parts that'll be cut out of an individual board. That allows for clamps. It makes it easy. And then you also have the variable where you can pick out, let me grab a couple of things here. I'm going to grab something, 1 second. So you could you can make decisions regarding the distance between them. Well, if you've got if you're using a 1/2 inch bit, of course, you're going to have a little bit of a gap in there of sorts, some judgments about that. It's very easy to use the nesting part of Rhino, RhinoCAM. I really like it. I've used it a lot. And it doesn't, you don't have to make it where your base form that you're nesting is some sort of perfect rectangle like it is out of here. I've done a lot of nesting in terms of mother of pearl. And mother of pearl is a kind of material that never comes in an even size, little pieces and little angles and all kinds of stuff. What I've done when I've done odd materials like that is I take my iPhone camera, I shoot a picture off of all of the parts together with a ruler down. Now I import that image into Rhino. And because I have the ruler in there, I could scale that photo correctly so that it is exact. And then from there, I draw a little outline around the shapes that I want to nest in. And then I tell the nesting program to drop in the parts that I'm cutting in that. It works out just terrific. So nesting is just super important when you're doing small parts. Somebody said, I recently switched from Rhino to Fusion 360. I don't regret it so far. Well, Bjorn, that certainly works. A lot of people use Fusion because, well, first of all, there's been this illusion that it's free, but now they're trying to gain control of that back and charge you money for it. But Fusion is a parametric-based system, and for some people that works out, really good. And there's a lot of value to parametric-based CAD software in certain situations. The reason I prefer Rhino is multiple reasons, but first of all, I really prefer the way that it works in terms of creating things. With a parametric system, you really have to define all kinds of stuff before you begin to really use it properly. Rhino allows you to sort of improvise from any direction, and that really works out really good for me. The other thing is Rhino's focus is not on solids. Solids, again, are typical in parametric-based programs like SolidWorks and Fusion 360, all the other Autodesk programs and a number of other programs. And there is, but I'm able to focus on surfaces. Yes, there are massive bandwidth problems. Is this for the other viewers too? I suspect that it is. I have to give you a bit of a caveat. This is one of the reasons that I hadn't done a YouTube stream up to this point. Where I live in a tiny community across from Seattle, across Puget Sound, a little waterfront community. And where I happen to live, where my house is, my shop and everything else, yeah, I think Tim's on a dial-up. Anyway, where I happen to live, the maximum bandwidth I have is 10 megabit with less than a megabit upstream. Now, that said, I'm hoping that'll change soon. Within 6 weeks or so, Elon Musk is going to be expanding his SpaceX system out there for satellite service. And right now, SpaceX service is 50 miles from me, right out, straight out to the coast. So they're getting pretty close. So I'm hoping he adds to that area. So somebody said, yes, I think Tim is on dial-up. So I can't understand anything Tim said. I am very sorry. And I can't do anything about this. I will try next time I do one of these to do it from my phone, which has a little better bandwidth. But at this point, I kind of have to go with what I have. I will tell you that I've had this problem even with Zoom calls before. So keep those questions coming. Somebody said I have Aspire and they're happy with it. Should I think about Rhino for some reason? Well, that's where it gets really interesting. You paid a lot of money for Aspire. There's certain things that Aspire does that the combination of Rhino 3D, which is the CAD part, RhinoCAM, which is another company that makes that product, to where they overlap a lot. The emphasis on Aspire is to make three-dimensional objects and to have the CAM routines to support them, so you can cut out 3D objects. So the basic answer to that question is it will probably get you exactly where you want to go, just like the combination of Rhino and RhinoCAM. So those kind of differences between a program, and because their price is kind of in the same range, if you combine Rhino and RhinoCAM together, you could probably get the two of them for minimal RhinoCAM for, I don't know, $1,100 or something like that. But that's kind of in the range of Aspire. Now, personally, I would focus on what makes you most comfortable. If you think there's a chance that Rhino would be better for you, I encourage you to try it. Now, Rhino has the most friendly trial program of anything I've seen. It's 90 days, everything works. They don't restrict anything at all. So from that standpoint, it's worth trying Rhino out. I mean, 90 days is a hell of a improvement. So one comment says he's getting pretty good from Southern Oregon, much better than our old acoustic modems. Yeah. Oh, geez. I remember downloading tiny little programs on 300 baud modems back in the early 80s. So yes, I've been there. So keep the questions coming. I'm going to talk a little bit about the bed behind me. Now, for those of you that have either attended my classes in person, which you know I've taught at Mark Adams for about 10 years, I think. And for those of you that have been to my shop and seen my setup, one of the things that you notice is I set up my CNCs in a very non-standard form. So the one behind me here, this is a custom CNC. It has two dual spindles. Its cutting area is roughly, it's over 3 feet wide by 6 foot long. And the way the bed is set up, underneath here, you can see there's MDF on top. I want to tell you about what's underneath. Underneath this are strips of Corson white oak, and with gaps in between these strips. These are 3-inch strips that have been cut down, and gaps in between them are 3/8. And so underneath here, I have these slats with 3/8 every 3 inches. And then every 3 inches, I have a center point where the attachment point is. So there's an attachment point here, attachment point here, and here, and here in the Y axis. And then going the X direction, I go every 9 inches. Hopefully you can get an idea, at least I'm pointing down here. And what's different about this is this material, the basic bed underneath, was all machined on the CNC itself. And as such, that allows me to have a very, very accurate bed with known positions. And I know that they're accurate because the CNC actually did the machining. So when I place something on this bed in a particular position, it's going to be that way every time I start up the machine, go through my normal startup routines, etc. At least it's going to be that way within probably a couple thousandths of an inch. And that's pretty good. A couple thousandths is not too bad. So this system here has worked out extremely well for me. I thought for sure that I would have chewed this up within the first year that I had this CNC. This CNC was built in 2014 by a gentleman by the name of Carl Bruce, by the way. Now, Carl Bruce lives in Bremerton, Washington, and his whole career in the last 20 years is just making custom CNCs for people. So what I have on top of here is the attachment I alluded to in the email that was sent out to the group that follows me at woodworking.digital. These are 3 different sections here. Now, let me talk about why I did 3 sections. The reason is wear and tear. So the idea of these 3 panels is specifically to cut plywood and MDF, flat materials that's never more than 3/4 of an inch thick. And I'm very careful about how I do my CNCing. I actually don't chew up my bed because of a variety of techniques, even in through cuts. I use a lot of tricks. One of them is I use a paper trick. I actually put paper underneath the parts that I cut, and then I lie to the machine where the Z level is. There's a lot of things that you could do. But I have found that particularly when I'm cutting Baltic birch plywood, that I prefer the cut that I get when I go through a little bit of extra. And as such, I prefer a spoil board. I don't know if you can see the details, but this is starting to get a bit chewed up here a little bit. So I want something sacrificial. Now, you can probably see a little bit of shadow lines here, hopefully. So I want something sacrificial, but I also want exactly what I get with my base platform here, which is I want registration. I want my parts to be put into positions that I know. I want the parts to line up. I want the material to line up so I can cut my parts out in a very predictable way. So to do that, a couple of things happen. So in the case of these 3 panels, you can probably see that there's little holes here. If not, just trust me, there's holes here, space to fit the grid that I have underneath here. That's part of these strips. So I'm able to just drop this on each time, each of these sections, I can put it back on. This whole setup will be in exactly the same position every time that I do it. So that gives me the advantage of, first of all, I can repeat the positions from the last time I used this. And also as I mentioned earlier, it registers to what I already know. That's good. So on top of this, I have my own kind of registration system for this, for these panels here. And stuck in here, I'm actually using just 3/4 inch dowels that cut down here. And then I have all these stop points so that if I grab, I'm going to grab a board here, excuse me 1 second. So that if I have some sort of board, I could place it on here and it'll register and it'll be machined. Now, the reason this works is, so I started with blank, in this case, 1/2 inch MDF. And then I attached this to the surface of my existing bed. Then I had the CNC mill in these positions here that are definitely aligned with the X and the Y axis. There's alignment over here and alignment over here. And again, you have to do this on the machine itself. So that's basically how it works. I can stick anything I want on this bed. It's going to be parallel to the machine, and it's going to be true, because that means this edge here will be true to the CNC, because the CNC cut these positions as well. Now, underneath this bed is a hold down system, and it's very simple. Now, I've been developing for a number of years a 3-layer hold down system, which Chris was on here a little while ago, and Chris is actually using a system that we discussed that's based on that, and it's a 3-layer system. But this is simply a 1-layer system to where the hold down and the positions are done in a single level. There's also holes throughout this bed that have embedded, let me make sure I got the right ones here, very shallow T-nuts. These are 5/16. In my case, as said, I happen to be using a 1/2 inch MDF material, and that gives me as much possible clearance in case a bit gets in a little bit deep. If you're using 3/4 inch material, you can obviously use a taller, like say a 7/16 of an inch T-nut. So these are countersunk into the bed itself from underneath. So now I have a separate hold down system that simply deals, with holding things onto this bed. And again, remember, this particular bed is designed to hold just things like MDF and plywood. So that means 1/4 inch, 1/2 inch, 3/4 inch, or 3, 6, 9, 12, 18 mil, whatever that you're working with. So one thing that I've done is create a set of clamps specifically for this job. And you can have a look here. Got a little bit of wood hanging on there. These are step clamps, and these are modeled after a fairly well-known metal clamp that's used for machinists. And essentially, the idea of this kind of clamp is that it locks into the top of the material. So in this case here, maybe I'll put it on there. So you can see that this clamp only overhangs about 1/4 of an inch, 6 millimeters, and it presses down. Because this is curved, when it's screwed down into the T-nuts that are embedded in the bed, it flexes and pushes down. Now, the advantage of these simple kind of clamps is multiple. For one thing, super low profile. So if I take this piece here, you could see there's not much overhang. So my odds of having a collision of a bit and the screw that holds everything down here is pretty low. Higher it is, the bigger problem it is. Now, I certainly have all kinds of clamps where where you can screw down things and do all kinds of stuff. But in this case, the advantage is low profile. The second advantage is one that's pretty subtle. You can see that L in here. So normally when you clamp things on a CNC for digital woodworking, a CNC router, your normal way to clamp is pretty much the way that traditional workbench clamping is done, and that's pressure to push the part down. And of course, the problem when you deal particularly with a smooth material like this, the problem with this material is it's inherently slick. And the longer you use a CNC in woodworking, the more that you'll recognize that clamping is one of the hardest things to do with wood. It doesn't tend to bite into the material. It doesn't tend to, there's not enough friction at the bottom to hold it in place. So you tend to press harder and harder and harder down. And that doesn't really do the job when 90% of your problem has to do with lateral movement. And that's, this way and this way, of course. So with the embedded system in here, I have all these hidden little areas where I can clamp. And I put them to where I could take advantage of base cuts that I would normally do. So I know that a lot of times I might cut out a strip of, say, 12 inches or so of a piece of plywood or MDF, and I might machine into that. So I have clamp positions that'll hold 12 inches optimally, and then 2 feet out, or 24 inches, and then 36 inches, etc. So I have them all over the bed, and it's worked out extremely well. So are those clamps made from wood and plywood? Let me grab something else to follow up on that. So normally, what I have been doing is I do make these simple wooden clamps. This is the way I have been doing it for small clamps for things, small objects and things like plywood and the rest of that. And then I would have these little screw things that would screw into my bed. In this case, the bed that's underneath. So you can make them this way. So to answer your question specifically, the answer is no. These clamps are made out of plastic. I 3D print a lot. I mean, a lot of stuff to help me in the shop. And the advantages of a 3D printer to a woodworker is really pretty huge. First of all, if you could do CAD, if you could do mechanical drawings, to do your woodworking, it's a really short hop to go from making CAD drawings that you might use to CNC something out in order to make something that you might 3D print out. And the advantage of that is just tremendous. All of a sudden, you can make things specifically toward the problems that you have right at hand. I mean, I can't even tell you how many things I make. In fact, I'm going to show you a bunch of stuff here when I move on to the next topic here. When you can run these out, and there's probably 3 cents in plastic here, and if it gets chewed up, I really don't care. I really don't care. And then I can make a clamp for a different shape. Now, these are optimized to hold 1/4, 1/2 and 3/4 inch plywood. But if I was making a set of clamps that I wanted to do, say 1 inch thick plywood, I would have, let me see here, a bigger foot at the bottom. So the whole clamp would be up higher and all that. Another subtle thing about this here, let me see if I can, 1 second, I got to reach behind me, is I'm really these kind of things. These are just waiting to get hit. So particularly on a project like this where it's low. So I actually use a little 4-volt screw gun. This is a Bosch IQ. I think this is their 6th generation. I've had a couple, or IXO. I think I've had a couple of these. I like them. They're small. They charge. It seems like the charge lasts for months. And I use those to screw my clamps down. So I use a socket head and screw in, and that's it. So essentially the advantage of 3D printing is, for a woodworker, is you can make things specifically to solve a problem with a particular project. So let me see here if there's any other questions. Designs the stumbling blocks, creating shapes and refining them, especially adding color when the design needs it. Practice, practice, practice. The best skill for design skill improvements. The answer is yes. If you haven't already, I did a whole video about a month or so ago. It's on this YouTube channel about basics of design for woodworkers. Certainly look into that. So are there any more questions about this bed system? Certainly put them up now. So essentially I do these 3 sections so I could replace a section when one gets chewed up. They're a little easier to handle than having one giant 6-foot by 3-foot heavy duty bed. They're easy to replace. I have my own registration system on here that's just 1/2 inch holes, and I use 1/2 inch dowel stock here. I mentioned 3/4 before, it's actually 1/2 inch. And I'm able to register a part on here, able to clamp it down on here really quickly. And then I'm able to cut it, do whatever I want. And as it goes through the material, it'll obviously chew up the spoil board a little bit. And that's okay. I've allowed for it. That's okay. Any other general questions? Because I'm going to rotate the camera here. Jim in Ashland uses the same bed design and happy. Well, that's good. So there's a much more advanced system that I've been working on for a while, but I just haven't had time to build it for this, that will use 3 layers. Keep your eyes open for that. I'll get into that at some point here. And it allows you to actually merge in fixtures and everything. So let's see here. Jim also said, I've tried to make small holes with a downcut end mill and find them not perfectly round. So no go. Larger holes, not a problem. Anyway, avoid the mill changes for your change for the small hole. Jim, if you can answer a question here, tell me about what CNC you use. That could be one of the variables here. Try to get to that before I move the camera. I appreciate that. What CNC do you use? What's the spindle? Tell me about what that is. So typically that would indicate something that is just not square on the CNC. In terms of making downcut end mill and you're trying to make holes, well, there's almost no situation where a downcut end mill in general would be a desired thing to use. I use downcut end mills to cut out large parts. For example, well, you can't really see it, but behind me, I milled up about $1,000 worth of mahogany this morning here that's 2 inches thick that I have to machine. And I do use downcut mills for that, but I don't cut all the way through it and I don't put holes in it. Chris says, I'm extremely happy with this hold down registration matrix system that I showed. That's Chris I mentioned before, Chris Morgan. He was taking delivery of a new CNC, and it didn't really have a bed. And I told him what I had in mind with my 3-layer system. He's adopted a lot of it. Okay, Shapeoko DeWalt 611. Yeah, I know I'm cheating. What's an optimal for small hole? I don't think that's a bad system at all, Jim. I have a Shapeoko XL in another part of my shop over here, and I have the same router. So essentially, the CNC itself is probably pretty square. The first thing to do is check if the CNC is cutting square. And the way you do that is the isosceles triangle thing. So essentially cut out one on the x-axis, let's say 10 inches, 10 inches on the other, measure the diagonal, also measure both sides, and it has to be the same. If it is all the same on both the sides of the, not isosceles, the equilateral triangle, if it's the same, then you're a square. But where you have problems with these kind of systems, like a Shapeoko and these smaller ones, Carve or X-Carve and all the rest of that, is usually with the router and the mount itself. Now, one of the things that can cause that with this pretty light duty setup that you have there is the fact that it could be you're diving in too deep with your I do things very gently on my Shapeoko. I'll take off maybe 1/8 of an inch a pass. I tend to use spiral passes using a more advanced routine that's in RhinoCAM, because that's what I use when I cut holes out that are not the same diameter as the hole itself. If I'm using a 1/4 inch bit and I'm cutting out a 3/8 inch or 1/2 inch hole, I use kind of a spiral down cut. And that usually works out pretty well, but I don't take too much, off at a time. So the first thing is well, for one thing, if you can use an upcut bit, because that will put less pressure on the spindle itself, and then take very gentle passes. Again, most of the time when I'm cutting plywood on a Shapeoko, I'm taking 1/8 at a time. I'm very slow about that. The other thing you could do is if it is the diameter of the bit itself, in other words, I'm making a 1/4 inch hole using a 1/4 inch bit, one of the most important things to do is use a micrometer or a digital, gauge to measure your bit. I guarantee you that no 1/4 inch bit is a 1/4 inch. And so you may be having problems there. The third thing is flex of the bit and the router itself. The Shapeoko is very vulnerable to that. I know that some people beef up the springs for the Z-axis that moves up and down. That definitely helps. Then the last thing has to do with the router itself. With due respect for the DeWalt 611, which is a great little trim router, the same would be true with the Makita. They're just not the same as a true water-cooled, air-cooled spindle that runs at higher RPM, have super precise, typically, God, now I forgot the name. Anyway, they'll have high-end bearings inside of them. And yes, A squared plus B squared equals C squared. Yes, of course. Anyway, so that is a problem with those routers. The other thing, too, that I've seen a lot is, I'm going to try to demonstrate this. So if this is your spindle, and this is the axis that it works on, like right here, you do check to see if your Z-axis is actually square. If you tilt a little this way, you will find that you're not going to get square cuts. It's going to be longer in this direction than it is perpendicular direction. So that's a really important thing to do. And he does ramp. Maybe I'm being too aggressive. Yeah, I would be considering that. Jim, you mentioned that it may be bit flex, but it also may be flex of the whole Z-axis mechanism. Now, there's a third party that makes a beefed up Shapeoko axis over there for the Shapeoko that just sort of revamps everything. I believe it uses linear rails and ball screws and everything, which are better. So in general, a spindle upgrade, you'd have to get on the Shapeoko forums to discuss, find out about it. A couple of ways to go. Typically, an air-cooled spindle, usually about a horsepower and a half, is the way to go, or a water-cooled spindle. But then you're going to have to deal with plumbing and cooling, with a water-cooled spindle. That is a pretty well-known upgrade for the Shapeoko. It is one of the weaker areas is the fact that it uses a regular router, but it is addressable, and it doesn't have to be terribly expensive. I actually have the whole setup to do an air-cooled spindle on my Shapeoko. I haven't had time to deal with it. One of the issues that I had to deal with is I need a slightly different controller, for it, because I got the wrong one. I need to do that. So that will take care of it. But look for flex in the whole Z-axis. Look for the mount to be square. And one of the ways you can tell square, by the way, with a router-based CNC is to do a surface pass, with a wider bit. A surface pass would be surfacing, like you'd resurface something. If you see lines in one particular direction, typically it would be, of course, in the Y direction on the Shapeoko. If you see lines, that means your spindle, or your router is actually tilted a little bit. And that tilted a little bit goes right along with that round hole issue. Anyway, I do have the Z upgrade with a hard HD Z bearings with a better, well, you've done a really good job. I would certainly be a little aggressive, less aggressive on your cuts, and make sure that you're square. And like I say, an easy way to do it is to do a surface routine over some flat material. And if you're seeing lines somewhere, you're not squared to the plane of the bit. Okay, that said here, I'm going to switch the camera around, and I have to give a little bit of a caveat today. Being my first live stream on YouTube, I backed off from some of the things that I have done even with the Zoom calls. I'm not using a multi-camera setup. I'm not using switcher-based software like OBS and all the rest of that. I've had a few problems with a Windows 10. One of their upgrades have messed up my video card a little bit, and I didn't want to take a chance. So I'm going to actually rotate this around. I'm going to show you a little bit about the workbench that I've been working on. Oh, last question here. Open Builds is now selling a router designed specifically for smaller CNCs, the Router 11. Yeah, that would be an ER11 kind of base. It supposedly has better bearings and less run out. Do you know anything about it? Not specifically, but those kind of router spindles are pretty common out there, because that size that we're talking about here for the Shapeoko is a pretty common size for engraving machines and all kinds of stuff. Don't know anything about it, but it could be a good solution. Since you have the Z upgrade, you should be off to a much better situation, but your spindle itself is definitely an issue. So I'm going to rotate the camera around. Give me a second to get things switched. And hopefully we still have, and I'm going to readjust a few things here, tilt it down a little bit. Okay. All right. So I'm going to move a light a little bit. Now, I have to warn you, I'll have to come back from time to time. I can't see my computer monitor from this position very well, so I will be going back and forth a little bit here. Let me get final adjustments on the camera, and then I'll rotate my computer a little, and hopefully that'll still work. All right. All right. So I alluded to last month that I was working on a project. And I've been writing an article working on this for really a long time. Actually, there's years kind of behind the basics of this. I wanted to build a new kind of workbench that's designed specifically for makers. Now, makers, there's no fine description of what it is, but they typically could be people that do woodworking as one of the things they do, but they might do other things as well. Now, in my last Zoom meeting, in October, I showed a little bit about how I was working on it. And because I actually held the article back, I decided to make a different base. I'm going to give you guys a little more of a preview. So I'm referring to this as a Maker Workstation, not a workbench. Now, I built about a dozen serious workbenches in my career, and they're all traditional based. Some have dog vices, some, excuse me, leg vices, some have front vices. I mean, there's been all kinds. I absolutely love workbenches, but I really felt that those kind of workbenches didn't work so well for modern woodworkers that might use a different range of tools. So different range, for example, you might be using a track saw, like the Festool track saws, which are just amazing, wonderful tools. You might be using one of those in addition or instead of, say, a table saw. And a lot of us use things like, Festool dominoes to make joinery. So I wanted to optimize everything for that. So basically, this bench is all made out of plywood and MDF. Yeah, that's kind of a weird material for a workbench, but it's extremely heavy duty. It's very, very heavy, and that's very deliberate. It's an open base design, as you can see under here. So you can store things and put things in here. And I have bins where you can pull them out and put them on top and store things, pull them out. So essentially there's 3 layers. There's a bottom layer, there's a mid layer, and then and of course a top layer. The top layer is made out of MDF, and the reason for the color is I've actually put some finish on this. I use Osmo Pollux oil a lot around the shop because it's very tough, and that gives me the chance to protect the top from glues and other things like that. So that's the reason for this top. Now, the good news is this whole thing can be made on a Shapeoko XL. Yeah, like I'm going to turn the camera a little bit more. There is a mid panel that was all made on a Shapeoko XL. This mid layer, it's all built in here. There's little slots in here that'll hold the side plates for mounting side items. There's major holes here, 3/4 inch in my case, for the dogs that go into the bench. There's through holes here, smaller. They're 5/16 inch. They have to do with hold downs and clamping and the such. That was actually made using a Shapeoko XL. The other thing is, and I brought this up last month when I did the last one, the Zoom meetings, is I've designed the bench so that even if you don't have a CNC, you could actually make this bench and make it precise using a new tool from Rockler. And it's essentially a drill guide, but it turns out it's a very precise drill guide. So essentially what you would do to make this bench, and you guys are CNC guys, I assume, so you're already off to a flying start, but to let you know other people can make it is you are able to start with a precise template. This template can make the entire bench. And you start off with a precise template, and then you basically caterpillar your way through using dogs for registration and that drill guide that I just mentioned. It's kind of out of reach, so I'm not going to go grab it at this point. So features about the bench. What makes this workstation a little bit different? Well, you can't really tell in the camera very much, but there's dog holes that go around the perimeter here, 3/4 of an inch, all the way around the outside. There's 2 strips here. There's a row here and a row here. There's a row in the middle and a row on the end. And the spacing between the dogs is all 4 inches. This whole thing is built on what I call a 4-5-6 grid. When the article comes out, I'll explain that a little bit more, but it's a very precise grid. And it's really important to get it precise. And again, by using the template that I just mentioned, you're able to do it right. Now, if you have a CNC, you've already got the way to do it. If you have a small CNC, the way that you would likely want to do it is this. You would make either the template that I just showed you a few minutes ago, I'll grab that again, on a small CNC, then you would use this to make the tops. Now, you could machine out each of these layers on a small CNC, but the odds on a small CNC of you being inaccurate and taking those inaccuracies and moving it through the system is pretty high. If you have a small CNC like a small Shapeoko XL, and this will be in the article, I'll show this as an alternate way to build it, I recommend you run out the mid-level step by step on something like a small Shapeoko XL. That takes 6 hops. You go a little bit, and then you move on, and you register to holes in the jig that I'll show you in the article, the special jig on the Shapeoko XL to make this bench. And you just keep moving along and moving along, moving along, moving along until finally you get the whole mid-level out. Then you would take the mid-level out and use that to lay it down and make the bottom level, which is slightly different, and the top level, which is almost identical to the mid-level. You'd use that to make that. That is an accurate way of woodworking. Let me check and see if I got some questions. I'm using AMB router motor, good price performance. Yes, that could work out really good. But the holy grail here is going to be air-cooled or water-cooled. That has ceramic bearings. It's very precise, a lot less run out. So if that's your goal. So anyway, the idea of this grid here, this precise grid is really important. So I have these dogs here. I 3D design. These are all designed in 3D, and they're all 3D printed out. Now, obviously, you can do something with dowels if you want, but they all go in here. You're able to register anything on the bed that you want, and it's going to be in a predictable position. So, for example, this, of course, is the template here. So I can put this template on this bed, and it holds it right into position. This is a little tight hole in this template here. So now I'm able to place something on this bed. So number one, you're able to change the nature of this workstation by simply using a different bed item or a fixture on top. So I already have dedicated fixtures for this, dedicated layers. So these plates, as I refer to them, so this plate here has a tighter range of holes in here, and that helps me with certain kinds of clamping. So if I'm doing a lot of small detail work that I need to hold or machine or that, I could grab different clamps. So for example, I have these cam-based clamps that allow me to take on different shapes, and by moving the cam around, I could adjust and actually tighten up to any kind of shape. Particular plate, which has a higher density of holes, it makes it a little easier to hold small things. Now, the second thing that's not really visible, this particular piece, is the what's going on underneath. I'll remove this plate, take this away, and you can't really see it. It's invisible. So in between certain positions on here are 5/16 inch holes which have 1/4 inch T-nuts coming from the bottom. So now all that stuff I showed you about clamps before, you know, those little clamps that I designed for plywood and other kinds of clamps, you can screw anything you want onto the bed. It already has its old holding system in place. The next thing about it is what you could attach to the bench. And this is something I actually worked pretty hard on. So one of the things you would ultimately want to run out are strips that follow the same 4-inch grid system. So now I'm able to put out strips here, and that makes it easy for me to resist movement for machine work. So now I have something on here, and I can actually work against this. Or if it's a smaller piece, I simply move it forward. So I'm able to do this. This really helps if you're doing things like making joinery, particularly using a fast tool, domino, for example. But it goes even farther. So let me grab a couple of dogs. So now I have this area in here. Now, if I wanted to hold something small, see if I can get this to work, I'll use a wedge system. So now I can hold a piece of wood in here and hold it, frankly, tighter than even a hold down clamp that you would use in a traditional workbench. There's also different sizes of these. They come in all kinds of forms and stuff. That's all part of the system. So you're able to kind of set up this bench to do all kinds of activities. The other thing that's modular about this bench is the attachments, not just on the top, but on the side. So I've developed the bench with a whole attachment system for the side. So for example, this standard front yost vise is a modular unit. It's all removable. And if I want, I could put it down here, or logically down on the end would be a typical spot. So it's a right hand, left hand kind of thing. And to reattach it, all I have to do is screw in. I 3D printed, made these little things here. Or I could use flathead screws so that there's no intrusion if I wanted to do something along the surface here. So that's part of it. So there's a whole side plate system as well. Also, one of the problems with a traditional workbench that I've always struggled with has to do with the situation of doing vertical work. It's always been a little less pleasing to me for vertical work. So in the case of this bench, I'm going to grab a couple of these. So it'll also, the plates could be attached to the front. So now, and there's a way to screw it on to hold it. So now I could do any kind of vertical piece I want, or anything that needs to be mounted vertically in here, and they go from there. The final part of the system has to do its interaction with some exterior items. I wanted the workbench to be expandable by use. And to do that, I don't think I could really show this. I'm going to see if I can move over there. Ah, there we go. Okay, this is a work sidekick table. This aligns up to the surface of the table with this top. So these tops on the work sidekick are totally compatible with the workbench itself that I have here. I'll get this camera back where I was. Get some of this out of the way. So now, all of these things register onto the bed. So now I could sit and I could attach tops and raise my work height, and also make use of these really nice clamps that you can get from Microchip, where you put in essentially a dovetail, and they work really well. I'm very surprised about that. So there's a lot more. It's on wheels and off wheels. That's a whole modular system. You can lift it up and all of a sudden the wheels are down and it's resting. This is super heavy duty. There's these big stacks of 5-inch thick columns inside that support the segments of the workbench. All of this could be made on a CNC, or if you don't have a CNC, it could be something else. So are there any last minute questions? I think we're probably, well, we've been at this for quite a while. Last minute questions before we shut this down. I'm going to rotate the camera around. We're still streaming. All right, there we go. All right, so any last minute questions about CNC woodworking, digital woodworking, however you want to describe it? Okay. Any last minute questions if we're still here? Okay. What do you use for freeform 3D modeling? I use Rhino. But there is some, there's a different kind of freeform modeling. It's called sub-D modeling. I had been using a plugin from a company in Barcelona in Rhino for a while. I also, before that, used a program that ultimately got bought up by Autodesk before that. And now in Rhino 7, you get true freeform modeling. And sub-D modeling, you're going to have to look it up. Essentially, it's an easy way to model and get more organic shapes. And in my sculpture work, that really matters to me a lot, organic shapes. I'm trying to get away from having things look like that they are geometric, which is something you would get with, frankly, any kind of CAD program. But sub-D modeling is built into the next version of that. I'm going to change over to a different microphone. So bear with me a second here. Hopefully this will still work. Run out of power in those AirPods, which happens all the time. Would somebody let me know if you could still hear me with this new mic? Because I've run out of juice on my AirPods. Can you hear me? Can you hear me? Somebody text back. Are your clamps on Thingiverse? No. Thank you, Jim. So it is coming through. They will be. I always share all my 3D models for things like this in Thingiverse. There will be a lot up with a lot of new designs and stuff. There are some really good cam clamps. I was going to decide instead. I'd seen